Okay, unit review. Simplify the expression. So to simplify an expression, you know your operators, because you got times, powers, powers. So underline the expression and make your 3 lines, and then that'll get the job done. That gets you where you want to be. So your bases, you have a 5 times x times x. So if I'm timesing by x twice, we just add the powers. So 5's to the 1, but that's in parentheses, so we got to do the power to power multiplying. 1 times 2 is 2. There's got to be 2 x's, that's why we wrote a plus. So you got 3, 3 times 2 is 6. And then the other one's just a 5, 6 plus 5 is 11. So you don't have anything on bottom to worry about. Now, the little power's positive there, so you keep that where it is. Positive there, so you keep the x where it is. And I can simplify 5 to the second. 5 times 5 is 25. So we have 25 times x to the 11th power. Okay, next one. 4 to the second times 4 to the 5th, 4 to the 4th. So we got 4 times 4 on top, so I'm just going to put a plus sign with that 4. Then with this base 4 on bottom. So I wrote down the bases. So on top you got a 2 and a 5. Neither of them are in parentheses, so that 2 plus 5 is 7. So 4 to the 7th, then on the bottom you have a 4. Now when you have something on bottom, you need to see if it can cancel. I mean, you have a 4 and a 4, so you want to get rid of the 4 with the smaller power and subtract that from the bigger power. So that's 3. So we added these 7 and subtracted 4, that was 3. So 4 to the 3rd, it's positive 3, so the base 4 stays in its position. And 4 to the 3, 4 times 4 times 4, that ends up being 64. Number 3, remember when you're multiplying fractions in algebra, you want to make it into 1 and simplify from there. So we have an x to the 3rd to the 4th times a 2, and then a y times an x to the 5th. Okay, so we have x times 2 as the bases, and on bottom you have y times x. Okay, so the x on top, you got 3. 3 times 4 is 12. And then the 2 is to the 1, but it just stays to the 1. Now y is to the first, but that's in parentheses, so 1 times 4 is 4. And then this x here is just a 5. Now you need to see what you can cancel. You can't cancel y, but you can cancel the x, because it's to the 5th, and then subtract 5 from 12, that makes 7. Okay, let's look at this. That's positive, so that is a stay. Stays in position. This guy here, that's a positive, so he stays in position. And that little guy there is positive, so that stays in position. So on top you can simplify the 2 to the 1st, that's 2. And then x to the 7th, y to the 4th. Okay, on number 4 we're trying to do the same thing. I didn't have enough room on that page to write it out twice. Okay, so you have 8 times x to the 6th times y to the negative 3rd, then a negative 2nd. And then down here we have x to the negative 3rd times y to the 2nd. So on top we got 8 times x times y, no repeats, so no pluses. And on bottom we have x times y. Now keep in mind the parentheses is only on the top, it is not on the bottom. So on top, anything I put here needs to be multiplied by negative 2. So I put a 1, 1 times negative 2 is negative 2. Then on the x, 6 times negative 2 is negative 12. Then on the y, negative 3 times negative 2 is positive 6. Okay, now on bottom we have a negative 3 and a 2. Those do not get multiplied because they're not in parentheses, but you got to see if you can cancel. XX. Well, we'd get rid of the negative 12 because that's smaller. Now when you minus, it's not just minus 12, it's minus negative 12. Now I'm going to write that over here so you can see the full effect. That's the same as negative 3 plus positive 12, which would be 9. Okay. So this ends up being a 9. Okay, now y's can be canceled too, but that's easy to do because you just minus 2, and that'd be 4. That was just a 2, so it's minus 2. Okay, let's look at that. That is a switch. So you need to switch the base 8 to the bottom so that its exponent goes to a positive. That's a stay. X to the 9th is a stay. When we write stay, it means it stays on the bottom in the same position it's in. Now, y to the 4th can't be simplified. 8 to the 2nd can. That'd be 8 times 8. This is 64. Then x to the 9th power. Okay, done. Now we're to the dreaded scientific notation. Both these numbers are in scientific notation. You need to multiply them. But how do you do that? Well, you multiply the non-base 10s. You take 7 times 2.3. Those are called your standard numbers. Then you multiply your base 10s together. Now here we just multiply. Okay. 16.1 times, and then to multiply here you go 10 and you add the powers. 5 plus 4 is 9. Now that might be the answer, it might not be. This is the first digit that's not a 0 right there. The decimal has to come right after that digit, and right now it doesn't. Okay, you got too many digits in front of it. So you move it left 1, so you put a 1 here, and when you move it left, you are adding, okay? Because you're making it smaller here, so then you compensate for that by making the exponent bigger. 9 plus 10 is 10, 10 to the power of 10. Okay, now division's the same thing. Okay, it's the exact same thing. You're taking a number in scientific notation, dividing it by another number in scientific notation. It's similar to this process, except you're dividing. So we have 2.5 divided by 5. Just set up the division like that. Then your 10 to the 5th divided by your 10 to the negative 3rd. So we divide 2.5 by 5, 0.5, times, and remember, cancel the 10 with on the bottom. You always want to do the bottom in scientific notation. I guess here it wouldn't really matter because we're always used to subtracting but it's not minus 3, it's minus negative 3. Well, now that's like 5 plus 3, which is 8. Okay, because when you subtract a negative number, you're actually adding the positive of the number. So it's 10 to the 8th. Now, moment of truth. 0 doesn't count. You have to go to the next digit. Decimal has to be moved after that one. You can't have just a 0 in front of it. You need one digit, but it can't be 0. So you're moving it once. You put a 0 there, so it's 5.0. You moved it to the right, so you're minusing 1. So it's 5.0 times 10 to the 7th. All right, now, first off, I wrote this like an idiot. I don't want that as a base 2. I want it as a base 10. Okay, just trust me on this. Base 10's too high. Let's put it as a base of, let's go 5. So y equals 1/5 times 5, put a caret symbol there. Now again, let's explain how it works. You can just watch this, okay? And we'll do it the quick way, but let me just at least show you first. This bottom half you don't have to take notes on, if you don't want. But I at least think I deserved a chance to show you how it works. Okay, let's just focus on the 5 to the x power, okay? So 5 to the 2nd would be 25. Okay. 5 to the 1 is just 5. Anything to the 0 is 1. Okay. Now, if I have 5 to the negative 1, you can make it positive by putting a 1 in front. So it's 1/5. Okay, because 5 to the 1 is 1/5. Again, you don't have to take notes till I say so. 5 to the negative second. Now if you put a 1 over it, you can think in terms of 5 to the second. So that's 1 over 25. Now you would have to go back and multiply all these by 1/5, okay, to get the actual y value, because you have a multiplier of 1/5. But I told you you could do it on a calculator, and you can. So 2, 1, 0, -1, -2. Calculator time. So 1ABC 5 times 5 caret 2, 5. Which is exactly what 25th times 1/5 is. It's 5. Okay, 1/5 times 5 to the first. That's actually 1, because it's 1/5 times 5. Now, I know this is 1, but when you times it by 1/5, it should come out as 1/5, which it does. Okay. Now, do your -1. You'll get decimals. That's okay. 0.04. 0.08. Now, if you want them all to be decimals, you can divide your 1 by your 5. I'm fine with that. It's 0.2. Okay. Okay, now all you have to do is make it to 5. Okay, well that should be pretty easy. Okay, we know we're going 0, 1, 2, -1, -2. You got to reach 5, which should be pretty easy just to make ones positive 5. So 2, 5, 1, 1. Then with these decimals, all you do is just get closer and closer to the 0, but you never actually hit it. So that's a growth because you're going up, and then you're just getting smaller that way. Do it the quick way, that's fine. Okay, y equals 3 times 1/3 to the power of x. So it's an exponent function, okay? Best doing that with variables. Now, if I wanted to do it the long way, which nobody's going to do, I'm not stupid, okay? So 1/3 of the second, 1 to the second's 1, 3 times itself is 9, okay? Anything to the first ends up just being itself. Anything to the 0 power fraction or no fractions of 1. Now, what I can do with that negative, make it positive, and you just switch the places on the 3 and the 1. So it's 3 over 1, which is just 3. 1/3, 3. Okay? 1/3 to the negative second. Just switch places, 3 over 1, and then that becomes 2. So 3 to the second is 9. 1 to the second's 1. We don't need the 1. Now, I would then multiply them all by 3, because we do have that factor of 3. But let's just go calculator. So 3 times 1ABC 3 to the power of 2. 1/3. Exactly what. I know we didn't get 1/3 there because we haven't timesed it by 3 yet. Okay. So if I would take 1/9 times it by that 3 in front, that would give you 1/3. That's why I get that. 3 times 1/3 to the first power. Okay. It's going to be 1. If you took that times 3, you'd get 1. Okay. That's a 1, but then, again, just use a calculator. I'm not trying to confuse you. Okay. It's 3. Parentheses. Remember, you got to get the fraction in parentheses before you hit the caret key. So it's 9. 27. Okay. All right, so we got to make 27. Okay. If it drives you nuts with that fraction, you can easily just divide 1 by 3. Okay. 0.33. Don't write a bunch of 3's. Just get out of that. So you have to hit 27. Okay, we'd have to probably go by 0. We'd have to make everything on the y-axis worth 5. 5, 10, 15, 20, 25, 30. Okay. So start where you're at the highest, the most extreme. Don't start up here because that's where I'm really tiny. Start here, negative, because I know I can go -2, 27's here. Okay. Those little tiny piddly ones, do those last. Those teeny outputs go last. The -1, 9. 0, 3. 1, 1. And then 2, 1/3. Remember, so this is a decay because the up goes that way, okay? Because 1/3 is less than 1 whole. You don't need to know growth decay, you just need to get it graphed. Okay, these are a couple quick ones. Write the expression radical form. This is a radical, okay? So you need to make a radical, and whatever that bottom is, that's your radical degree. Now cross it out. And in the radical, you put a parentheses with 3x, and you can put the 1. Really, if it's a 1 power, you don't need it, but that's the answer. That's all I need, okay? Now you're going the opposite way. You're getting rid of the radical. So you write what's inside, and you underline that power and put a 6, okay? Now it's a rational exponent. Rational exponent means it's a fraction exponent. Okay, now I have this formula on the board, the compound interest formula, okay? A equals P, you don't need to make boxes, tables, nothing. The formula's right there. 1 plus R divided by N, and then power NT. It's right up on the board. Customer deposits $600 in a savings account that pays 2.5% interest compounded quarterly. How much will the account be worth in 5 years? So we have to know what goes in. We know we're finding A. P is your principal, that's 600. That's a no-brainer, okay? R is your percentage as a decimal, so 2.5. Now I know that's already a decimal, you still need to back it up twice, okay? So it's 0.025, okay? N is the frequency. Now that changes from problem to problem. This is quarterly. Quarterly is 4, okay? Because there's 4 quarters in a football game. There's 4 quarters in a full year. And then N again, which we already have. And then T is the years, which we have is 5. Now we put them in and we can't miss it. So P is 600. 1 plus your R, 0.025. And then N is the 4, caret, and then N times T. So 4 times 5 is the power. Well, that's 20. We can go to our calculator, but we should probably get that as a 20. So 600 parentheses, you can hit times before parentheses. If you don't, it'll pick it up as a times. 1 plus 0.025 divided by 4, close it. Hit it to the 20th power. 679.62. That's how you do compound interest. Okay, now in our next problem, now we're going to need the box and table. Okay, because this is not interest. So the population of a city is 45,000. Whoa, it's 45,000. I got too many zeros. It's 45,000 people. It decreases 2% each year. If the trend continues, what will the population be in 15 years? I didn't throw any little tricky ones. There was a time earlier this week where there's some little tricky stuff. Not this one, okay? People, years. Years is X, people's Y. So per, people per year. Okay, people each year means per year, and it's 2%, and it's decreasing. So you put minus 2%, and since that's not people, since it's by a percentage, we have an exponential function, okay? So we will not be making the line. We're going to make the table, but we're not going to make the line. So I take one. I have to, if it's an exponent function, that's a decay because minus. You have to come up. You have to take 100% minus 2%. That's 98%. 0.98 is the factor. So X is years, Y is people. So 0, 1, 2. There's going to be none of this 0, 5, 10, or any of that stuff. Okay. So you got 45,000 people to start with, then you don't add, you start multiplying by the decay factor 0.98. Remember, since I'm multiplying by something that's less than 1, it takes it down. So 44,100. $43,218. Okay, that's enough of that. Put your 15 years there, question mark, and you go down here and write your equation. You don't make the line graph because it's not linear, it's exponential function. So that is a times b to the x power equals y. So my a is where the y starts, it's 45,000. Then the b is the factor I was multiplying by, 0.98 caret. And we know that's going to be just 15. You don't need to divide it like you did that one day because you're just going by 1. So it's to the 15th power equals y, and then I just bada bing, bada boom. Okay, 33,236. Don't put a decimal because you can't have that for people. Okay, and the last problem, this might be on the test, it might not be. Scientific notation. The human body normally produces 2.2 times 10 to the 6. The first two story problems, those kind will be on the test. I haven't decided on this one. Human body normally produces about 2.2 times 10 to the 6 red blood cells per second. So put that, that's an actual amount. How many red blood cells are going to be produced in 30 minutes? So per second means you got 2.2 times 10 to the 6 times seconds. Now the problem is that's in minutes. Well, you can convert that to seconds simply by multiplying it by 60. Because there's 60, because I mean 1 minute 60 seconds. If I got 30 of them, 30 times 60, that's 1,800. So you're multiplying, you're going to take your 2.2, the basic numbers times each other, and then that's the only base 10 we have. So I just put that there. $3960, put a decimal at the end, and then the 10 to the 6 just remains here. Now, ain't the decimal supposed to be after the 3? It is. So move it 1, 2, 3. So this time you'll be adding a 3. You moved it left, so you'd be adding it. So it'd be 3.96. You don't need the 0 times 10 to the 9th power. Okay. Just put that down there. That might be on the test. It might not.